Hey everyone, I'm Nikhil. I work in anomaly detection in time series, and today I'm going to be presenting a system that we designed for anomaly detection in cyberphysical systems. And it's called illiad. We're kind of smart about that. But yeah, anyway. In the next 15 years, it's estimated that about 60% of the global population is actually going to migrate to urban environments. And one of the main challenges that comes up with this is actually scaling the electric grid. And the electric grid, the way it was designed a long time ago, so it's a very complex system to just scale to meet this demand. So we also have to actually consider renewable energy sources and many other sorts of energy sources that we're not tapping into right now. So this figure just depicts the current energy consumption estimates from the US Department of Energy. And if you look at the top left of this figure, you have a few renewable energy resources. And you can tell that we're really not tapping into these resources as much as we could, because solar and wind contribute very, very little, like 0.01 and 0.92 to the total 98 quants of energy generation. So a solution that was proposed by a UN committee was basically coming up with these things called microgrids, which actually incorporate renewable energy, but are also distributed generation stations, which are completely dissociated from the grid. The way they're dissociated is that microgrids are able to operate both in like islanded and grid connected mode, meaning they're able to operate independent or in conjunction with the electric grid. And in the figure here, it basically shows like a generation station, transmission and distribution stations, and a few homes. So this was a setup that we actually simulated in our experiments and tried to detect anomalies in this setup. Another advantage for of this is as you get more distributed generation, it also sort of reduces the vulnerability towards cyber attacks because the risk is minimized as you get more distributed. So just some basic terminology. A cyberphysical system is just a distributed system exhibiting uncertainty due to interaction with the physical world. So you basically have an interface between the cyber and physical worlds. And microgrids are examples of this. So monitoring and alerting mechanisms for such critical infrastructure is paramount. And one such example is the 2003 blackout. The cascading of the 2003 blackout that actually caused the entire Northeast to shut down could have been prevented when it started in Ohio if the monitoring system was working and actually detected the anomaly in a timely fashion. This is actually something the committee that investigated the cascade found after it happened. So this is just an example of the topology that we used. This is a standard IEEE 33 bus power system. And we also added a few other components like electric vehicle charging, solar panel, simulated a wind turbine, something that we hope will become ubiquitous in like urban environments in the future. And at the bottom is actually the learned invariant graph. The way we do it is we basically use three algorithms, autoregression, factor analysis, and Kalman filtering to do the state estimation and learn both local and global dependencies. So basically, if you consider any two nodes here, each node can be considered to be a sensor, which outputs like, let's say, a voltage or active power or something. And then relationship between two nodes are actually learned using Kalman filter, autoregression, and stuff. And the important thing here is we also leverage the network topology because a power system has a fairly constant network topology that doesn't change with time, and it's known. And our hypothesis is that you don't need to consider global relationships because all anomalies that happen globally will propagate through a sensor's local relationship to get to that particular sensor. So this is sort of one of the hypotheses we worked on. And to know more about how we sort of detect anomalies and how we learn invariants and how we sort of combine these three algorithms, please visit my poster. I'd be more than happy to explain. Thanks.